Okay, so before we get started, let's talk about particle accelerators. The Large Hadron Collider, or LHC at CERN, is basically a giant 17-meter ring with really strong magnets. It's the biggest particle smasher we've ever made. It's powerful that it can almost recreate the earliest moments of the universe. Can this machine find out about secrets of the universe, help us with even bigger stuff? CERN, that started in 1954, is a top research place with 23 countries involved, plus a lot of scientists. It's where great minds come together to invent things. The LHC is CERN's main project, but it's just one part of a huge set of particle accelerators and experiments. Think of it as a racetrack, but for tiny particles. The LHC speeds up protons to close to the speed of light, then smashes them together. This produces energy like in the Big Bang with crazy hot temperatures way hotter than the sun. Magnets keep the protons going where they should, and special coolers keep things colder than empty space. The beams hit at 4 spots on the ring where there are particle detectors called Atlas, CMS, ALICE, and LHCb. Each one checks different things in particle physics. It's like have giant cameras that take pictures of these crashes. The researchers look for the leftovers to find things like the Higgs Boson or God particle and other particles that could teach us how the universe is made. By checking this small stuff, we get to know about the whole universe. Every time we learn something, there's always another question. The LHC isn't just for science. It's proof that people are curious, and it shows how far science has come. It confirms that we want to learn and understand the forces that shape the universe. But as we learn even more, we have to think about what's right and wrong. What could happen when we investigate the unknown? Could we accidentally lose control? At CERN, something new come up that worries the scientists. Brian Cox, who used to work at CERN and knows a lot about particle physics, said the LHC wants to make a little Big Bang. He also talked about what this might mean, like findings such as the Higgs Boson, and dark matter, the secret stuff most of the universe is made of. Just imagine making the stuff that makes up the universe. It sounds cool, but it has big risks. This small Big Bang is not just an idea. It's real. The LHC makes heat, pressure, and energy that is like the beginning of the universe. It's like actually being there at the start. With that power, we have to be careful. What if something goes wrong? Something actually did go wrong. In 1978, a Russian physicist named Anatoly Borsky had a bad accident. While he was working on a machine, a beam of proton struck him in the head. It went through his head, but he didn't lose consciousness. He walked to get help. He was still able to think, but the beam hurt some tissues, so he had hearing loss in one ear and face issues. This confirms the particle accelerators can be strong and dangerous. We can't ignore the dangers of a particle smasher like the LHC. There's a risk of odd reactions and confusing the basics of everything. This isn't just a movie idea. Real scientists said they're worried. One of the scariest things about the LHC is that it could make a little black hole. Black holes have so much gravity that nothing, even light, can escape. They suck up stars and are very weird. The thought that the LHC could make one, even a tiny one, scares people. Could it grow and eat the Earth? CERN people say it would be wobbly and disappear fast. But people are scared and amazed at the power we have because of that chance. To understand how the LHC could make a black hole, you need to know the basics. When protons crash together at nearly the speed of light, so much energy is made that it bends space and time. Think of a trampoline. If you drop something heavy on it, it bends. If it's heavy enough, it can make a hole so deep that everything gets pulled in. That's kind of what can happen at the LHC. There's a theory that there are other dimensions we can't see. If they're real, the LHC could use them and make a spot with gravity that forms a tiny black hole. This got scientists like Stephen Hawking curious. He said that the Higgs boson could get unstable at very high energy, which could cause a vacuum that could mess up not just Earth, but the whole universe. Sir Martin talked about a worst-case issue where a failed test could cause vacuum instability. He said it wasn't likely, but we should still think about it because the risks are so high. The CERN scientists did experiments, studied theories, and planned to keep things safe. Brian Cox said, "Everyone worries about the LHC, so they have safety plans and checked everything to keep the LHC running safely." Cox said the energy is normal for Earth, and the chance of a black hole is very low. Scientists think it would be small and wobbly, then disappear in a burst of energy called Hawking radiation. It would be quick and then gone. Some think the LHC could open a door to another universe. Most scientists don't believe this, but some people fear it. What's on the other side? Could we accidentally lose something we don't know about? This idea has been overhyped in the news, so people worry even more. How did this idea start? And what does it mean for science? Extra dimensions are nothing new in physics. String theory says there might be dimensions we don't know about. These could be hidden, but can be reached under crazy conditions. Think of the LHC as a key that opens locked doors. When protons crash with a lot of energy, they could make the ripples to check out hidden dimensions. If these dimensions are there, the LHC could show them. While the LHC is strong, there's no proof it will open a door to another universe, especially one that is scary. Still, the unknown plus the odd nature of quantum physics makes people interested. Should we be scared about the LHC and what it might do? It's easy to get scared, but the CERN scientists know the risks. They made sure the experiments are safe, and they're always watching and checking. The good that could happen from this research is a big deal. Things such as learning more about the universe, find new particles, and learning more about dark matter. This is not just humans being smart. It's a way to see into the universe. Like other big steps in science, there are dangers, but we should be curious, respectful, and careful. The Large Hadron Collider is where science is at its best. It's where ideas about physics meet tests. It can answer big questions such as where mass comes from and what dark matter is. Even with safety plans, the LHC still feels like a mystery. The size and energy of the machine are amazing. Each new experiment takes science to new places. Most scientists think the LHC is safe, but there's still things don't know. What if problems come up that shift how we see physics? The LHC is checking the limits of what we know and how much we can control nature. Since the particle crashes make conditions we haven't seen since the Big Bang, these experiments make us think about messing with the universe's building blocks. Still, the LHC has done a lot for particle physics. It found the Higgs Boson, which has helped us open doors for new advances to shape the future. Even with the risks, trying to learn is something to admire. The path of science isn't easy, and the LHC is the same. The experiments examine the edge of physics, where what we think we know might not line up. For years, It's been hard for physicists to understand the forces of nature, such as gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. These all make matter. The LHC confirms the humans are smart and curious. It's taking us forward by bringing smart people together to understand the secrets of the universe. The LHC wants to answer questions that people have had, such as what are the forces that run reality, the true pieces of matter, and how did the universe get here? The LHC has already proven the Higgs Boson is real from 2012. They're still pushing what we know. Every time protons crash inside, a chance to find something new happens. From new particles to things we've never seen. With great power comes great responsibility. Scientists know about the risks of experiments, such as controlling the forces that started the universe or creating many black holes. Physicists such as Stephen Hawking warned about issues that could happen from vacuum instability. While the chance of these issues are low, it makes the public scared and interested. To some, the LHC represents humans trying to control nature, wanting to control the forces of the cosmos. For others, it's a tool to see how reality is created. Trying to learn comes with discoveries. Just like all science, there are questions about if things are right, along with dangers we don't see coming. What happens when we can see the universe's secrets? Should we worry if we're ready for the answers we could find? Besides the risks and the amazing things possible with the Large Hadron Collider, or LHC, its existence has asked some big questions. The size and complexity of the LHC force us to think about what we know and how we know it. Scientific discovery has always challenged our knowledge, but the LHC works in a way that observation turns abstract, and data needs to be interpreted with math. When evidence is hidden in quantum uncertainty, we ask, how do we know what's real from what's made up? The LHC that helps with working together. No country could pay for a machine this big alone. It has scientists, engineers, technicians, and students working together with a common goal. This helps to bring countries together when they're split most of the time. In a way, the LHC isn't just for science. It's a symbol of the world uniting for knowledge. The discoveries at the LHC could help scientific subjects. For example, knowing about subatomic particles could help with chemistry, nanotechnology, material science, and medicine. This could make imaging better, computing faster, or new energy sources. Basic science has made way for tech changes. Early scientists had no idea quantum mechanics would cause microchips and smartphones. The amount of data made by the LHC is amazing. Detectors collect data each second from millions of particle crashes. To understand this, CERN has had to create data processing systems and algorithms. To have high-speed computing, the World Wide Web was made at CERN in the 1990s. Now, their system connects supercomputers across the world. This data analysis helps with physics and breakthroughs with artificial intelligence and machine learning. There's an interesting cultural view of the LHC, since it involves dark matter, antimatter, extra dimensions, and the beginning of the universe. It's captured the public in a way few science projects have. It appears often in media. This is good and bad to it. It can excite people about science, but it can also spread wrong info or fear. That people talk about quarks and bosons shows how powerful the LHC has hit beyond scientists. Ethical concerns are still changing. Should there be global regulations of high-energy physics experiments? Just as there are treaties on nuclear weapons and genetics, Some say testing the limits of reality should have rules. It's not just about great failure, but about proper knowledge. Once a finding is made, who picks how it's used? At the same time, the LHC is part of education and helps PhD programs, internships, and research. It trains future scientists and engineers. These people take their skills to other industries, helping to advance across the board. The LHC goes beyond physics and helps computing, communications, electronics, and finance through modeling. What makes the LHC unique is its modesty when facing the unknown. Unlike areas of science that work with expected results, particle physics says not all experiments will have answers. Many discoveries at the LHC have been debated for years. This patient way shows uncertainty in a world used to quick results. The LHC tests how we see the universe, not just in scale, but in purpose. Should we learn about the universe because we can't or because it has meaning for us? Are we driven by curiosity? Or is there a hope that we can answer questions about if we're here, our purpose, and even knowledge? Whether the LHC finds the secrets of dark matter or extra dimensions, it is what it represents. Humans always search, ask, and understand. It reminds us that changes begin with the smallest particles, and that when we look at the edge of the universe, we're also looking at ourselves,